Calculus forum. Today we are going to look at the second method of differentiation. In the previous class, we were able to look at the general method of differentiation. Today we are going to look at the new concept in the second method of differentiation. The second method of differentiation is first principle method. And under this, the following is the concept areas to use. The first content or the knowledge you should use in this method, you should be aware of these two items. The first agenda is to know whenever you see y, you have to add their change in y. And where you see the value of x, you have to add their change in x. Add change in y to y and change in x in x. When you see y, add their change in x. And when you see x, change in x should be added there. Y should be added to change in y, x should be added to change in x. Let us now use an example here to derive this question. An equation states y is equals to x. Then they have asked you find dy all over dx. This is our question. How can we do it? So we have said you have to add change in y where you see y. So our y plus change in y is equals to x plus change in x. Whenever you see x, add there change in x. I think this example has been fitted now. Then the second concept area, we said make change in y the subject of the formula always. By making this one the subject of the formula, then meaning y will be going to the other direction to be in the next negative side. Then it will be change in y is equals to x plus change in x minus y. But we have to remember our y was equals to x. So when you see y, you put there x. So this y we replace it by x. Though we say change in y is equals to x plus change in x minus x. So this x will cancel this x. Then we will remain by change in y equals to change in x. Then the last procedure always, we must divide both sides by change in x out of change in x. So our answer the question asked us to find dy all over dx. So our change in y, our change in x is equals to 1. That's our final answer. Now let us look at the second example. The second example has said y is equals to x squared. Then we said you add change in y whenever you see y. So we have y, we add change in y, which is equals to x. Our x, we add change in x, but our x was squared. So meaning x plus change in x, all in bracket should be square. Then we have to expand this one. X plus change in x squared. So let us now use this side to calculate that one. X plus change in x. Meaning this function will multiply by itself, change in x. So we take this one times this one. It's giving us x squared. This one times this one. It will going to be x change in x. This one times this one. It still give us x plus change in x. Plus the last in it will be x times change in x multiplied by change in x, which is going to give us change in x squared. So our final answer will be x squared plus 2x change in x plus change in x squared. We have now completely expanded the concept. So after expanding this one, we are going to get this one. So we replace it here. Then we say we make now y the subject of the formula. After replacing, we make y the subject of the formula by saying change in y is equals to x squared plus 2x change in x plus change in x squared minus our value of y. But what was our y? Our y was equals to x squared. Our y was equals to x squared. Now we replace the value of y by x squared. Then lastly, our equation, this one will cancel with this one after replacement of y. So we make change in y the subject of the formula. So we will have change in y, the subject of the formula, change in y is equals to 2x change in x plus change in x squared. So always the last procedure we always make, we divide both sides by changing x. So by changing x, by changing x, by change in x. So change in y should be equal over change in x will give us 2x plus change in x, because 1x will cancel with this one, will remain with change in x. But whenever you see a change in x somewhere, if your answer remains with something like change in x, always remember to use the limits by saying changing in x should be equals to 0. So we have to replace, whenever we see change in x, we have to replace there by 0. So change in y should be over change in x is equals to 2x plus 0. So our final answer will be 2x. That's why when you use the general method to differentiate the function y is equals to x squared, your answer will be 2x, the same as this one. So basing on different methods of differentiation. Thank you for the nice lesson, and I wish you a prosperous day and hope that you have enjoyed your lesson. Let's meet next time for the next method of differentiation. Thank you.